Okay, day 71. Today's lesson is on mortgages, and that, in fact, we're following up the research that you did on mortgages with a lesson today, and a little more mathy and a little less research today. But the goal is to solve problems using real-life applications of annuities in the 3-minute review here. So this is a review question. This isn't probably last days. This is probably review from other days. That's okay. Use an annuity formula to find the amount. Keyword there, amount. That means at the end. That means A we're using. Of $100 investments, 12% gives us all the details. It's this formula because it's regular payments, and I'm given R, $100 regular payments. And I've got A is what I want to find, R is 100, I was 12%, but it's monthly, so that goes nice. I don't have to keep that into my calculator. N is 8 years, but 12 times a year is 96 payments. And then I can just fire this up and into a calculator. So $100 a month for 8 years adds up to almost 16,000 bucks. That's pretty good. Now that is a pretty high interest rate. It's hard to find these days. Hard to find an investment that will give you 12% compounded monthly. But if you did, the annuity is worth at the end. Into the graphing calculator. If you need more help and review, that's good. Finance, PDM solver, and our N was 96, percent was 12, present value was 0, because when we invest $100 a month, we're wanting to know how much it grows to. And it's not weekly payments like that suggests, it's monthly payments. Monthly payments, and that'll switch automatically for us. Future value is what we want to find. And we got a different value. What did I do? I put in 99 months, and you probably saw that. Well, thanks for pointing that out. 96. $15.90. Yeah, same number. Good. I write those in there. Actually, no, I'm not gonna. I'm gonna pull the same old trick. You're gonna write them in there. So there. Once I copy this. Nice. Math-wise, what's the main difference between a mortgage and an annuity? It felt like the same thing, this idea of a regular payment, but hopefully in your research yesterday you found the difference. And the difference is mortgages or interest is compounded at most semi-annually, and payments are often monthly. So the idea here is this is the payments per year, this is the compounding periods per year. For mortgages, usually it's monthly payments for mortgages, but compounding period can only be twice a year. And that's just weird, right? This is for mortgages. And all of the annuities that we saw, that these two things matched, those things matched, that was an annuity. And that's the big difference math-wise. There's some other differences about things that happen when you default on a mortgage versus an annuity or whatever, but we're worried about just math-wise today. Okay, so on to the lesson. 7.7, solve problems involving mortgages. Interest on mortgages in Canada are calculated interest is calculated. It should say is. Well, that's okay. Is calculated semi-annually. And that's just by Canadian law. But usually, people pay their mortgages monthly, sometimes weekly, sometimes twice a month, or sometimes every other week. But usually, mortgage payments are monthly. And that causes problems mathematically. This means that we can't use our annuity formulas. Payments and compounding periods must match. So remember, our annuity formulas was this, right? And here the I was, interest rate per period, and N is the number of periods, and these things matched. If it was monthly, they matched, but it doesn't, right? One's semi-annually, one's monthly for mortgages, so we are stuck. But happy day, we can use the TVM solver still. So here goes Ferd. He's buying a house. It's pretty exciting. He's a grown-up Ferd today, buying a house, and there are the details. What are his monthly payments? Well, notice that it's 20 years, and remember what that's called. The 20 years is the amortization period. That's how long it takes you to pay off the mortgage. The amortization period is 20 years, but monthly payments, 12 times a year, 240 payments. His interest rate is, and that's what interest rates on mortgages are about right now. The present value, that's how much the house is worth now. And then in the future, he's going to pay it off, and we want to find the payment. This is the one we're going to solve for. Notice we have to be careful when we put this part in now, because the payments per year were 12, but remember, on a mortgage, this has to be 2. So I've got to change that. Even though the calculator wants me to switch it back to match, that's not the case. So here we go. That's 240. 3.7. Present value is $175,000 house, which is a pretty nice house, probably. In the future, will have paid it off, so the future value is 0. Payments are 12, and notice I got to switch this to 2. When I switch that to 2, and this looks strange, but this means it's a mortgage. 12 payments a year, but interest is compounded monthly, or sorry, semi-annually. And now I'm going to go back to payment, and I'm going to solve it. Bam, right there, 1030.45. So his payments are 1030.45, which is reasonable. That's a reasonable mortgage payment. About $1,000 a month for a house seems reasonable. How much interest does he pay in total? Well, this is going to be a little bit shocking, I think, for you. Well, notice how much actually comes out of his pocket. Well, his payments were 240 payments of 1030.45. But he only borrowed $175,000. That's what the house was worth in the first place. When I put that into my calculator, I get a somewhat surprising number. $72,308. Yes, that's right. He paid over $70,000 in interest. And this is the little formula for interest. No wonder banks have record profits. Poor old Ferd's paying $72,000 in interest. All right, onward. Let's see what else we got. Example 2. Let me see how we're doing for time. I'm going to stop there and pick it up in part 2, folks.